Hi, my name is Andrew, and today I'm going to be talking about the FASTQ format. In this RDMbite, you will learn about the data stored within FASTQ files. This includes raw sequence, sequence quality, as well as data on how the sequences were generated. We will also cover basic manipulation of FASTQ files. FASTQ files are the standard, text-based format for high-throughput sequencing data, of which the basic unit is a sequencing read. Unlike the 2 lines of a FASTA file, each read in a FASTQ file has 4 lines of information. First, a unique sequence identifier, the raw sequence of A's, T's, C's, G's, and ambiguous N bases, an underused description line, and the quality score, an assessment of how confident the sequencing machine was at each position. At a basic level, sequence headers start with an @ symbol, contain information on the sequencing machine and the specific location within a flow cell where that read was generated. It may also indicate the sequencing index used and indicate if the read is paired. Over time, sequencing headers have grown to include additional information, including additional IDs for tracing your workflow and QC flags. In this case, an N means the read did not fail QC, and a 0 indicates this was not a control read. Certain sequencing machines never use control reads. Headers can also include other information, like an accession number if it comes from a public database, or the read length. Quality scores in FASTQ files tell you the probability of a sequencing error at each location, where the higher the score, the more confident the base call. Quality scores decrease if there are multiple sequencing library fragments in a cluster, or if the polymerase skips, confusing the fluorescence used to identify the order of bases. Quality is assessed by a Fred score, a play on the name of Professor Frederick Sanger, who won a Nobel Prize for his pioneering work on sequencing, and his eponymous Cambridge Institute was where the FASTQ format was invented. Fred scores typically range from 0 to 40 in short read data. Double digits cause problems when you don't know which integer matches with which base. The solution was to encode quality using the ASCII character coding system, starting either at the 64th character, the @ symbol, or at the 33rd character, the exclamation mark. In both cases, a single character is used to represent a Fred score and can be clearly associated with the base it describes. Most modern sequencing data uses Fred 33, but care must be taken, as a capital J in Fred 33 is a 1 in 10,000 chance the base is wrong, but is 1 in 10 with Fred 64. There is no set requirement for FASTQ extensions, but they typically follow these conventions, including indicating read pairs. As FASTQ files are so large, they are typically zipped, most often in .gz compression. You're likely to want to look at these files in a Linux environment. Use zcat and head to check the first few reads, remembering they come in blocks of 4 lines. You can sort FASTQ files by splitting into columns, sorting on the sequence ID, and converting back to rows, zipping if needed. You can identify a single read by name, using the grep-A3 option to pull out 3 lines after the matched read name, and the -M1 option to take the first match, saving search time. Remember, you can't just pull out sequence identifiers using the @ symbol, as these can appear in the quality score, including at the start of the line. That concludes our look at the versatile, information-rich, and widely used FASTQ format for high-throughput sequencing data. Take a look at the links associated with this video for more information and more RDMbites in this area.